This presentation gives an overview on masonry. So what are our major topics? We'll go through a little bit of a quick amount of the history of masonry. We'll take a look at how the mortar mixes are made and what they consist of, what they mean. Grout, what it is as a definition. And brick, both types, bonds, and joints to give an idea of brickwork. We'll take a look at structural clay tile and concrete blocks, CMU, concrete masonry units. Other topics: masonry panels, gypsum block, glass block, stone, and stone masonry. So, history. One of the oldest manufactured building materials is what brick is. And sun-baked brick was found in the remains of structures going back as far as 6000 BC. Romans also used brick, and in 1633 the first brick buildings were erected on Manhattan Island. So masonry defined: it's an assembly or combination of small building units made of clay, shale, concrete, glass, gypsum, or stone that are set in mortar. Masonry consists entirely or partially of hollow or solid units laid contiguously in mortar. And now mortar, the main thing is that we have to remember is it must conform to the ASTM C270 standard. And there are four basic types of mortar used. They're given letter definitions: M, S, N, and O. And they're generally composed of Portland cement, hydrated lime, sand, and water. And often now some acrylic polymers and different additives are also added into the mix to give better water and moisture resistant properties. Also makes them a little bit more flexible and longer lasting. And the key to forming a strong and durable bond with masonry units is really making the correct mortar mix. So here's some of the mortar types to give an idea. M type is good to 500 psi. The average compressive strength, that is, the per square inch compressive strength is how it's defined. And it's used for masonry below grade and in contact with the earth. Then we have S, the S type, which is good for a compressive strength of 1800 psi. And that's used where maximum flexural strength is needed, and usually required where winds are greater than 80 miles per hour. So think of that as for usage in hurricane-prone zones. We need to have some flexibility and strength combined. Then we have the type N, which is 750 psi. We've dropped off a lot in the compressive strength amount category here with N type, but it's generally used as an exposed masonry above grade, parapets, chimneys, and exterior walls that are subject to severe weathering. Then finally we have O type, 350 psi, very, very small compressive strength. It's used for solid unit load-bearing walls where the compressive strength is less than 100 psi. So some of the properties and functions, well, what mortar should is not shrink very much at all. It needs to have very little shrinkage, otherwise cracks would form in between the bricks and voids, and then moisture would get in, and if there's a freeze type condition, that even expands the joints more and we get a lot of damage. So they also, the mortar properties, they need to have a higher degree of resistance to moisture penetration. And that's what I was talking about earlier, where the acrylic polymers help even reduce that further. But definitely, the Portland cement already has a good amount of properties for moisture protection, preventing moisture penetration, that is. And they need to possess adequate strength to resist the forces applied to it. Remember the weight of the weight of the bricks, the one on top of the other. Then you have the other thing like wind and shear and type of compressions that are working on the brick face, the facade. You also have another problem with the possibility of any type of seismic activity, which is earthquakes, and so the bricks have to be able to resist all these items. Movement in the building itself. Remember, buildings actually move in high winds. They have movement. They just simply they bend and they twist, and bricks got to follow along with all this, not to a great amount, but enough that it's significant. And the last final thing is to give the aesthetic qualities, and what that is what brick is really excels at. People enjoy it just for the look, and there's nothing like a stone-faced building to a brick-faced building to give a good look and a good solid feeling to a building aesthetically too. Some more mortar basics. So brick masonry mortar is made of Portland cement, hydrated lime, and sand. And stone masonry uses white Portland cement for the non-staining effect. Then we have what's called retempering, which is adding water to the mortar mix to maintain consistency. That's why while the workmen are doing the work, to keep it, you have to add water a little bit at a time. But remember, the mortar mix should be used within 2 to 2.5 hours after the initial mix is prepared. If not, it should be thrown out. Now, efflorescence. You've probably seen this. That's that. It looks almost like somebody went and put some powdery substance on the outside of the brick or the mortar. It's fuzzy. It almost looks like a growing mold, but it's what it is efflorescence. It's caused by salts in the brick or mortar that are brought to the surface. So it's really a mineral. It's you can think of it as a crystalline growth. Rather, it's not biological in any means. It's not a mold or any type of thing like that. Even looks a little bit like frost, how frost forms on a cold day. So mortar joints. Joints vary. The facing brick type, 3/8 to a 1/2 inch. Building brick are right around a 1/2 inch for the joint sizes, and for glazed brick, even as little as a 1/4 inch. And although many types of joints exist, and we'll take a look at those, the most weatherproof and recommended are V-shaped, weathered, and concave. Those really help the joints be a lot more efficient than a simple flat joint. But joints, they may be formed by using a trowel, steel rod, or specialized tools. So if the concave type, we'll look at that in the next slide. But if you've ever seen a mason as he's working, he has a rounded tool that he passes along after placing in the mortar, after scraping the excess away with a triangular type the tool. He ends up going over it all with a curved type shape to depress it in a little bit and to gives it a finished look. But there's a function to that too, that prevents water damage, the moisture getting into between the bricks and the mortar joint. So here's some of the type of the joints. You see the concave one. That's where you've passed that second tool. It looks like a half-rounded piece of metal tool. You could even be done with a round tube, let's say, that would give the same effect. The flush type is just when you've cleared with that triangular type trowel, just cleared the face of the brick straight. You have this other type called the struck type, where it's back, turned to a 45-degree angle. Don't see that too often, but that's how it is. Then there's the weather joint, which makes more sense because it allows for the runoff of water. And then you have the recessed type, which is called a raked finish, where the mortar joint is recessed in behind the face of the brick. And finally, you have this last one here on the far right, which is another variation of the raked type. It's some sort of recessed type of joint. So grout. Now, what is grout? Grout, the water-cement ratio is less critical in grout than in mortar or concrete. And it is intended to be very fluid in order to function in its binding capacity. You have a slump. You know the slump test, same as a kid at the beach taking a little sand bucket and turning it upside down. If all the sand sticks together and the outline of the bucket is there's no slump. But if you do that, if you were to do it with mud, depending on the consistency of the mud, it would slump, which is it would just start to expand out to the sides. And usually you place that on a 1 foot or 1 foot board. Use a bucket, a small bucket, and place it upside down. And the amount of spread at the base of the mold that you've left behind, it's going to tell you is what's considered slump, and it's measured in inches. So another thing about grout, it may be used to fill cavities between masonry and masonry walls. Now, remember, there's a weep area, what they call. There's a void between the brick and then the other type of material that makes up the walls. So let's say we have wooden construction with a plywood sheathing. Then we have a moisture barrier outside that, like a Tyvek or a tar paper in the old types. Then we have a void, and then the brick is placed. And the bricks are held to the wall with these type of, they're brick ties, they're called. They used to be the old, I used to call them a waffle type. They look a lot like a, um, almost like a crinkle chip or potato chip, and that type of configuration. They are no longer allowed. They have they're now mostly stainless steel type U type bolts, and basically what you do is you place that right in the mortar that goes between the bricks, and when that all dries together, that allows to have connection to the wall, but while still maintaining that void, which is a weep area for water and moisture to be able to pass between the brick and the wall surface where the moisture barrier is. Very important to have that. Otherwise, there's always some moisture that gets through the brick, and without a weep area, everything would be in contact with the even the moisture barrier. Even if you had that, it would still transfer moisture right through to the wall assembly. And like I said, if you have a 2x4 wall assembly or a 2x6, all that moisture would be transferred. Never mind the thermal type items that would be transferred too through the wall. So the weep area is critical. And here, that's why you say the bottom, you may be used to fill cavities. Well, now and then, there's certain areas that you do have to fill between the between the brick and the wall. Sometimes I call it a pancake of mortar or grout is placed between the bricks just to give a little bit of adhesion. But it depends on the situation. Around windows and lintels, and you may want to fill the cavity solidly. So the weep area is treated a little bit differently. You don't need a weep area when you need a little bit of cohesion between the wall and the brick facing. So what are bricks? Bricks may be solid or hollow core. They're called that way. They're either solid masonry units or hollow masonry units. And the cores, or the holes, are called cells. Just to say, cells should not exceed 25% of the volume of the unit. That's a good one to remember. When you look at a cinder block, the cells should not be more than 25% of the volume of the unit, those holes. Now, bricks vary in size and color and shape and texture. There's many different types. But let's take a look at the solid type to begin with. So solid brick versus with holes. And solid brick is used where holes may be unsightly, like in steps or window sills. You wouldn't want to see the holes in the brick. You ever see the bricks with the 3 round holes? Well, you have to use a different brick when you're doing work around the window. Let's look over the lintel over the top of a window, and if you were just to see holes in the bricks, that would definitely not be sightly. So what do the holes in bricks do? Well, they help the units fit fire properly. That's when they're made in the kiln, so that they don't bend and twist so much. That's why the holes are put in there. They also promote bonding with mortar, so you can imagine that they get filled in a little bit when you squash that one brick over another on your layer or lines of brick, and fills that round hole a little bit. That gives a lot more bite to the bricks, and they do reduce the overall weight of the brick, and also makes the units easier to handle. So those are good things to remember. So what are your classes of bricks? Let's say we break it down to some basic classes of brick, and one is adobe, which is the sun-dried clays with a binder. Now in the old days, the binder would be straw, just simple straw. They would hold it all together a little bit better. Well, nowadays it's different types of binders. The other type of brick here is kiln dried, made of natural sand and clay or shale. Those are the most widely used. The kiln burned means they're heated up in a kiln, fired like pottery is, and they get solid that way. Then you have the sand-lime mixture, which is pearl gray in color. Dolomite lime is mixed with clean sand, pressed, and allowed to harden in closed vessels under steam pressure. So there's another type. And then we have the concrete type, like the CMUs, or concrete masonry units, which is a mixture of Portland cement and suitable aggregate, and those are formed in molds. And usually, because they have their concrete type mixture, they don't need any firing and kilns. They dry. They dry actually right out in the weather conditions, or in a large factory warehouse type setting, just being covered from from to prevent rain from interfering with the drying. But they do need some bit of moisture to be able to make that full set. They can't be allowed to dry out under the sun and totally under uncontrolled conditions. So a little bit about brick kilns and how bricks are fired in a kiln. They're usually done in 4 stages. One is called water smoking. That's at 400 degrees Fahrenheit. Then dehydration. That's where you pop up the heat quite a bit, between 300 and 1800 degrees Fahrenheit. Oxidation is another stage that's 1000 to 1800 degrees Fahrenheit. And finally vitrification, which is the really high heat, 1600 2400 degrees Fahrenheit. And of course, flashing, what is called flashing, which is reducing the oxygen in the burn in the kiln, produces different colors or color shading. If you ever wonder how those bricks have that reddish black look, and it shades as that's how it's achieved, by doing flashing. And then the cooling down time, it takes 2 to 3 days for the bricks to cool down, and the rate of cooling will affect the cracking and the color. So you get just a general rule of thumb, you get less cracking when the rate of cooling it takes longer, like 3 days or 4 days. The cracking is more evident when you you cool them a lot quicker, and that's where you get the cracking. So that controls that, and it has some of influences on the color as well. So some different types of bricks, types and sizes. Well, the common type is a common brick. That's what we call it in building. It's the most widely used. It's the dark orange to a deep red color. There are a lot of finishes and sizes available of that type of brick, and it meets ASTM C62 grading criteria. The SW type is one of them is severe weathering for exposure for heavy rainfall and freezing. In other areas, used MW, moderate weathering, for average moisture and minor freezing. Let's say that's in the southwest. SW would be used in the north part of the country. And then you have NW, negligible weathering, for exposure to moisture and freezing. So that's in the real temperate climates, maybe the tropical type climates as well. So face brick, this is another type. It is made from clay, shale, fire clay, or a mixture under controlled conditions. That meets the ASTM C216 standard. You have a lot of appearance types. The FBS for general use and exposed in interior walls where wide color ranges and variations in sizes are permitted. Then you have the FBX type, used in exterior and interior walls where a high degree of mechanical perfection is needed, and they have a narrow color range and little variation in size. And the FBA, which is non-conformity altogether in size, color, and texture. So each one is a little bit different. Think of that as a kind of like a field stone. When you make a field stone wall, they're all made out of stones of different sizes. That would be more like that type. Finally, you have this glazed face brick, which is where the ceramic glaze is sprayed on the brick, and then they're fired at a high temperature. So they're a lot like if you ever seen stoneware, those type of plates and all that. What they are is they are also glazed. So it's got that glossy finish. Almost looks like it was painted on, but they're done in the firing process. That's how that's achieved. So the finishes may appear dull, satin, or glossy. You can get them in all three. Fire brick. A lot of times those used, of course, doing around fireplaces. They're used as chimneys and incinerators and a lot of industrial settings. You're building your backyard grill out of brick. You're gonna want to line it with fire brick. Withstands those high heat fires. That's what you want to line an oven with. So, or an outside type stove, but they're used, of course, in the chimneys as well. And those are made of clays with a large amount of alumina, silica, flint, or feldspar. They hold up better to the high heats. Now we have paving brick, or pavers, and they're burned at high temperatures to make them resist water and wear from traffic. So we have this idea of nominal size versus actual size. The law, like in lumber, where you call it a 2x4, but it's not really 2 inches by 4 inches. That's why it is. That's why we have the nominal, even though they're called a 4x2 and 2/3 by 8 brick. The actual sizes are 3 5/8 by 2 1/4 by 7 5/8. That's just for the modular type. The utility type, you can see how it differs as well. So just remember, there's nominal and actual sizes. That the two types of ways of calling bricks. So brick bond. Now the bond is the arrangement of bricks in rows of courses, and the bonds are designed for appearance, and they're used to tie together a structural outer wall in a wythe type situation. Wythe is analogous to the word width, to an wythe to an inner wall. You can see, well, we'll take a look at it in the next slide, and I'll give you an idea what a wythe looks like visually. So a wythe is a vertical section of 1 brick thick. Here we have wythes. Look at the top center. Each one is a row. It's a width of brick, a wythe. Now, look at the different ways of placing these bricks. You have these different types of rows. These are the bonds. The courses of bricks is you see in the dark shaded portion on the upper left. What it is the joints. Vertically, joints are staggered one over another. Now there's a reason for that. It provides a lot more strength. Now let's take a look over to the row below that on the left in the middle, and you can see that you could do what's called a header course, where you're really using the brick to bridge and close across 2 different rows of brick when you're doing a double brick wall like that. So that's an important thing too. Now you have a few other types that aren't shown here, but they're called the soldier course. The soldier actually is down there on the bottom in the middle. That's when they're standing up. And now it's easy. We like to think of a soldier course, if you want to remember which type of brick it is and it's standing up. Think of a soldier standing at attention. Those are used in different places, sometimes over windows and under windows. It can be it gives an architectural look, but it also has a little bit of a reason behind it for structural and for maybe catching up on the rows. But here the bricks are stacked straight up. Now here we don't show the other type, but if they were the flat face, the longer face of the brick was standing up and placed to the outside, that's called a sailor type, so in opposition to the soldier. And the way to think of that is they're wider at the base, just like sailors when they stand on the deck of a ship. They have their legs spread. They don't stand with their legs together, heel to heel. They have their heels spread out because the ship yaws and rolls, and that's just a sailor's position. So that's the difference of the positioning of a soldier in a sailor row. And just to make a little explanation on that. So here's some of the bonds. Now you can see these patterns. The Flemish bond on the far right. You use small bricks that are long brick, small brick, long brick, small brick, and that makes that type of pattern. If you ever begin looking at a brick facing, they're not all the same. They use all these sometimes combinations of these bonds, and of course the running bond on the top left is the most common. Then you have the one in the middle, the common or American bond, that uses a little bit of a combination of different things. Then you have that English bond, and of course the stack bond. That's where they're right on one on top of the other. And then the English cross and stitch. So there's quite a few different types of bonds or patterns that are used when placing the bricks. Like I say, take a look at brickwork or masonry. At one point you'll see, oh my gosh, all the buildings, they don't all look the same. They all have these different items. So again, now looking a little closer at the English and the stretcher bond, and why it's called a stretcher is because you use the brick, a long brick, that's called a stretcher when you're using it the long way. And the other type is a header. That's usually to bond between 2 rows of brick. Now for architectural reasons it could be just sometimes it's just a piece of brick placed in there, but here we have those special headers that connect between the 2 rows of brick or an inner row of any other item. And of course then we're showing that as opposed to clapboard and diagonal siding Those are regular siding materials. And there's your soldier row down below once again. So let's take a look at how it looks in real life. Here's your red brick for one type, the common flame red. What kind of bond is that? Do you remember? Well, anyway, they're all this. I think they're all pretty much the same bonding pattern, except the one on the lower left. But if you remember the bonding patterns, then you could take a look and compare them to these. These are just examples of the looks of bricks. So brick walls may be bearing on supports of vertical load or non-bearing, and solid walls have two or more whites bonded together by ties and headers. In cavity walls, you have two walls spaced 2 inches apart by metal ties, and you may fill the cavity with insulating material. Here they mention the weep holes must be in outer wall in order for moisture to escape. And these type are not allowed though in earthquake zones. A little bit more about brick walls. The faced walls are brick masonry units bond to a backup wall of another material, common brick or hollow structural clay tile or CMU. So those are what's called faced walls. Then you have veneered walls, which is facing material that is securely tied to a structural wall but not bonded to it. And that's used in common residential wood frame construction. So that's the difference between building with if you're building with that wood construction on the inside, you can't bond the two. You have to use brick ties. Although in masonry you can use the grout to bond between the CMU wall in different spots and spaces while still maintaining your weep area. Then finally you have reinforced brick masonry, which is steel reinforcement that is placed vertically and horizontally, and often grout surrounds it. That's like I was saying, where you use lintels over the windows. Use a metal angle lintel, something out of solid metal, and then you fill in around it to give it a little bit more strength. And that the spacing of the grout is often governed by local code requirements. A little bit about ties. They may be standard units or adjustable ties. That's the two types, and general types. And number and placement of ties depends on the application and building code requirements as well. So here's what some of those ties look like. That corrugated wall tie on the bottom is now no longer allowed to be used. We used to just screw it to the wall. Used with like the wooden construction type. That's where you need these ties, or that's why you can attach it to the wall a little bit easier. It could be metal stud wall as well. But at any rate, now we're using the metal types on the top left and the top right. The Z tie, which is a multi-width walls, used for multi-width walls when fully grouted, and the adjustable box anchor type tie, and that's designed also to be tying multi-width walls. So structural clay tile, this is another one. These are burned clay units. They're larger than bricks with vertical or horizontal cells. They can be smooth, roughed, or score-faced if you've ever seen them. The score-faced always sticks out in my mind. They may be load-bearing or non-load-bearing, and they're usually made of terracotta, ochre to red in color. They're very light because of being made of the terracotta. That type is used in a non-load-bearing ornamental type material. You see those walls when they've been broken into the very little lightweight pieces. Almost they make the sound of glass when they fall because they're fired at a high temperature. So here's a little bit more on the structural clay tiles. The clay tiles used in a backing for a brick wall, if you were looking at it that way, or the 8-inch clay tile wall. How a corner looks. In the old days, they used to build walls out of these tiles and then gypsum or plaster over them, and that was those were interior walls. They were made up of these lightweight types. You find them in older buildings. So a concrete masonry unit, the good old cinder block as we call it, where many of us have seen that. They're hollow or solid masonry units used for interior or exterior bearing or non-bearing walls. These are generally now used for interior walls. Those old red brick ones I talked about before are no longer being used, and the aggregate to make the units will determine the weight of the block itself. Say 25 to 50 pounds for an 8-inch by 8-inch by 16-inch stretcher unit. Just to say, they also come in a U shape that you can place metal bars in them, rebar, and then fill them with concrete. And sometimes the concrete masonry units are filled with concrete to give them more strength, then they come like a solid wall. Of course, they have a good, here's the nominal widths first, the 4, 6, 8, 10, 12-inch lengths, so on and so forth. The lengths, sorry, that's the widths, and then the lengths of 6, 8, 12, and 16, and 24. They do have a good fire rating. They have good thermal storage capability. Now, and they're good resistance to sound transmission, and they're economical, so that's why they're used quite often, especially in strip malls and let's say garages being built, the automotive garages. They're pretty commonly found there. So here's some of your CMU types, the different profiles. You see the top row. You have sometimes you have the end blocks there, the two in the middle. The one on the far left is for working along through the middle of the wall. You have the rounded edge, which makes another idea if you're using that at the corners of the building. Then you have other different types of ideas for interlocking type bricks. You see the U-type that I said down in the third row, third one over. That's for laying the bars, rebar inside, and a few other different odd profiles. So CMU screen units, well, they're used to form what's called a screen wall for privacy walls and carports and the separation of spaces. Have you ever noticed that where they have, you can see right through. They're only made for architecturally, yet they allow you view through the unit. A lot of times they're made of the clay type or the red type as well. A little interesting idea. There's all different variations of that. So surface bonding, which is block bond, is where a CMU is laid dry with vertical steel grouted in place. So 2 coats of block bond is sprayed on inside and outside of walls, and the surface may be textured and requires no paint. And the colors include white, beige, and gray. Those are used, that's for quick construction. The wall is already done, the concrete masonry unit wall, and then painted right away. So gypsum block, those are actually just gypsum. They were used too to make interior walls. They're very soft, like chalk, lightweight, used in non-bearing applications, but they are highly fire resistant and used in interior locations. And the one thing is you should never use them in areas where moisture and exposure could occur. I've seen them used in old hotels to divide bathroom walls. Not a good idea. A lot of efflorescence ends up happening. They degrade real quickly with moisture because they are chalky in consistency and nature. Glass block, very decorative. The ones that you can see right through, made out of glass itself, and these are considered masonry unit as well. And then they're used for decorative effects, but they also provide controlled light transmission, so you get a light daylight coming through them. They may be used above a door, let's say. They're good insulating. They have good condensation protection, and they have good sound reduction. So the glass blocks are pretty popular. The one thing about they're formed of 2 cast glass shells that are fused together. If you ever notice, it's like a masonry material that forms a hollow unit, and contains a partial vacuum. And the vacuum decreases heat transmission and condensation. And the faces can be smooth textured, opaque. You can get them in green colors, white colors, even this golden type, how do they call that? That's a sepia type look, just to say. So glass blocks are common sizes given here. We'll take a look at what they look like on the next page. So they're usually laid in a stack bond, but they can support their own weight. The only concern with glass block is it expands 1.5 to 2 times more than a brick wall, and therefore must have expansion joints. So here's what the glass block looks like. Interior type considerations used a lot in bathrooms and showers. There may be a little vestibule type idea on the interior, used to transmit light wherever you want to get some light in, but not be able to see. Maybe as a side light beside a door, entry door, for that type of idea. Well, let's take a look at stone. and the different classifications. So stone, igneous stone, is that formed by solidification of molten rocks such as volcanic activity. That's granite. Sedimentary is formed from silt and marine life and rocks that have been deposited by running water. So that's your travertine, the limestones, and sandstone. It's been compressed under the weight of water and over time turned into a rock. And the third type is metamorphic, which is an igneous or sedimentary rock that have been changed by pressure, heat, or moisture. And those are your really hard, more of the harder rocks like marble and slate. So stone, the general removal method, of course, is quarrying. If you ever watched a quarry, how they do this in quarries, it's pretty impressive. Taking out giant chunks of stone, even the granite and so on and so forth. They're cut through with giant metal diamond blade saws. They come out in blocks that maybe weigh 20, 30 tons. They're like 15, 20 feet by 10 feet by 10 feet cubes. And then they're cut into the thin layers. I call it a bread cutting machine. It looks like they're taken out of the out and cut that way. It takes a couple days to cut through them, and you end up with a marble for your countertop, with maybe being an inch and a half thick. And of course, these are all natural stones, but some are cultured in man-made stones that are used. Those are kind of done like a type of concrete mix, and they're made in a factory. So they have those, obviously those Caesar stones, or Caesar stone is one used in countertops. It's synthetic. So what are the stones used for? Well, granite. Look at the ranges here, wide range, all kinds of wall facing, paving and flooring as well. Limestone. Limestone doesn't stand up as good for floor work. That's the thing. It's soft, but its colors can be anywhere from buff or gray. The cream colors, they're the most common. I think that's what they mean by the buff. Used also in exterior walls, but copings and sills for exterior work. And the thing is, they do a lot of moisture can easily be transferred through limestone, but there's ways to take care of that with different synthetic products that are now applied to the stone to make them waterproof. You have marble, mostly countertops, but a lot of flooring as well, wide range as well. Sandstone, exterior wall facings, sometimes used as pavers. Slate can be used as pavers, very strong. Can be used as roof tile as well in the old days, very expensive. Great to work with, very common, making a comeback. Slate is used even on walls and wall facing. And there are some soft slates as well, just to say, I think it's called Indian slate. And then you have travertine at the very bottom, which is another limestone product. So here's some of the examples of the different looks of stone. Aesthetically, they're great to work with, of course. And stone masonry, let's break that down into three categories. And that's based on the shape and the surface finish. One is called rubble. Those are stones that are collected, like field stone, or as they come from a quarry. That's the rough stuff. And then they have ashlar, which is constructed of squared stones set in rammed-in or uniform courses. That's where the mason has to be really good at figuring. He knows how to figure a pattern and use those stones to make a wall come out straight somehow and in some way, because he has all these odd-shaped stones. Then you have, of course, the cut stones, which are dimensionally cut. Those are like bricks. They're milled and ready. They come in common sizes, like the bricks, 4-inch by 4-inch by 10-inch long, and those are easier to place, of course. But most stone masonry is done on the odd shapes and sizes. So here's some of those odd shapes and sizes. The rebel type, using regular field stone, taken right out from the earth. Then you have the ashlar type, where you have different sizes. They've been cut a bit, but they're all of different sizes, different cuts, as you can see. So what about masonry restoration? Well, we have 4 different reasons for deterioration. I spoke about a little earlier, that freeze-thaw cycle, which causes fractures. Also a wet-dry cycle. That's another problem with common. That's why, too, you don't let common, CMU units dry out too quickly. They tend to crack. That's why the temperature control and the moisture control is made. But going through that cycle, and as the wall is exposed every day outdoors, causes the cracking problem over time. So then you have the thermal expansion and contraction, because even though rocks expand and stone or bricks expand and contract and change with temperature, not as much as wood or metal, but they do. Salt crystallization, that's the efflorescence. So those are the common problems that you may encounter. So masonry cleaning, how are the different types achieved? Well, one is a water mist that will remove surface deposits and the entrapment of moisture. Some people clean them with the pressure guns now and the water pressure. So that's one type. Now chemical, which may damage the masonry, that's usually done with the different chemical items that you can buy through the market, but you have to be careful about what you're doing. As with the next one, muriatic acid, you may want to etch the surface and clean it, but you have to be very quick and wash it away quickly. Otherwise, muriatic acid just eats stone. It's as simple as that. And you could do some damage there and change the color, get discoloration and items like that are not suitable or not desirable as an end product. And then there's the abrasive type, like sandblasting, and that's where pressure washing is also included. But that can also damage the surface and remove mortar. So we have to be careful with all these different types. So with the cleaning of masonry being covered, we'll conclude this presentation. I want to thank you for participating.